Watch my. All right. So we have this particular question we're going to answer. That's from NECO 2025. All these things, both JAMB WAEC, I've told you there is no difference in certain type of questions they ask. They cover almost similar outline. Are you following, right? So we just answered this one. This is pure JAMB question. We took it from here. We are given this diagram and we are asked several options. Which of the options is correct about the motion of the car? Whose motion part was traced? Is that not so? We found out that the options given to us, option A, the statement that is true about this motion is that the car A decelerates between point F and G. Sorry, between point F and H. B, accelerate between point F and G. C, has a constant speed between points E and F. D, has no acceleration between points F and what? G. And we'll find out that the correct option is what? D. Because between point F and G, there is no acceleration. This line is a constant speed line, constant velocity line. So acceleration is equal to what? 0. So no acceleration between F and G. Now, the next question we have here is taken from NECO 2025. It is a velocity time graph related question. And I'm dictating the question there. I guess some of us have written that a body with an initial velocity u, accelerates non-uniformly to attain a velocity v after a time t. Are we there? Which of the following velocity time graphs represents its motion? Which of the following velocity time graph represents its what? Motion. So we have these options here. Option A, because it is NECO 2025. And that's actually question 2 for us. The option A is in second. So here we have 0, 0. Which of course is the origin. Then this is the shape of the graph. Are you following, right? Here we have V, and then here we have U. Then we connect. Something was connected this way. You know, dot to the time axis. Are you following, right? Then dot to the velocity axis. Make sure you're sketching it. Be fast. Option B. This is the diagram given. Option B. This is the diagram given 0, 0, and then we have something like this. Trace to this. This is time. Horizontal axis is in seconds, and then we have velocity here, meter per second. Then here we have this label U, and here we have V. All right, can I fix option C here? Option C, we have a similar diagram, time in seconds, then origin 0, 0. The non-uniform graph outline is given like this. Then we have U, we're given here to be V, then time. We have velocity axis, velocity meter per second. We are used to this concept already because we've treated velocity time graph. Is that not so? We define velocity time graph as a graph that shows the relationship between velocity and what? Time. So the graphs are not something new to you. The only thing is that this is non-uniform motion. And in non-uniform motion, you know that velocity, you won't have equal velocity in equal time. Are you getting me right? Uniform acceleration is defined as when equal velocity is covered in equal what? Time. That is uniform. That's a similar kind of graph we have here. Equal velocity in equal time. This one now is non-uniform. So you can see you are no longer having a straight line. Rather, what you have is what? Curve. Is that not so? So I want to find out what the correct option would be from this. Option D, oh no, we have this. Permit me to transfer option D and E to this side of the board. Option D, we have something like this. And then this is 0, 0. We have this, something of this kind, a curve like this, dot, 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 dots, dots, dots. This is velocity axis in meter per second. Then we have this as U. We have this point as V. Then we have T. This axis is time axis. Then finally, option E, we have this. We have this. This is a velocity axis, meter per second, time axis in seconds. And then we have 0 here. Then this moves this way, something of this kind. Then dot, dot, dots, dot, dot, dots, time. Then this is U, right? Now this is V. And then this is U. Good. So these are the options provided. These are the options provided. Are you there? Now I'm going to read out the question once again. I'm going to read out the question once again. Why were you not sketching this since? All right. You would have to look at the board, please. You can sketch it once we are done. You can always take a snap of it. Because, like I said, make use of technology. And you know in our school, to an extent, for good reason, I'll allow you to use your device. Is that not so? Because we need to move. Let's be done with this so that we can move on into our main focus for this class, where we are going to deal with equations of motion. Is that not so? Now let's go back to the question, please. It's okay, right? You can look at the options as you try to choose what the correct answer is. Let us read the question once again. You have the question there written already. A body with an initial velocity u accelerates non-uniformly to attain a what? Velocity v after a time t. The question I'm reading is not written on my face. The question I am reading is not written on my... So at this point, as I'm reading this question, if you are looking at my face, then you are not learning. What I am reading is there in your notes. So look at your notes. At this point, all of you should be looking at the notes. You've copied that question. It's just the options left. Look at the notes as I read the question once again. I'll be fast. A body with an initial velocity u accelerates non-uniformly to attain a velocity v after a time t. Which of the following velocity time graphs represents its motion? How do you analyze this question? With the options given to us in terms of graph, I don't want to catch anybody writing anything again. I've told you you can draw it later or you can snap it. Are you following right? In either way, so we'll move on to our main thing in the class. We just have to at least review 1-2 questions from velocity time graph stuff we've done. How do we know that this graph is defining non-uniform motion? We know that the graph here is defining non-uniform motion because none of this graph here is a straight line graph. You are seeing curves, is that not so? We just finished the concept of our quadratic equation by graphical method, and you see something like a curve, right? So you want to differentiate between a linear graph and what? A non-linear graph. A linear graph, the graph is a straight line. We just answered one question, you saw straight lines connected, is that not so? So because these graphs you have here are curves, are what? Curves. These are non-uniform motion graph. Now, which of them is the correct answer here? Now, let's look at the question here, please. We are told that a body with an initial velocity, u. So the initial velocity is what? Which means when it was moving, the original velocity, it started with this what? U. Now we are told that it accelerates non-uniformly and attains the velocity what? V after a given time. That time it was quoted to be what? T. So think of somebody that is driving a car. And then once you enter, you start moving. You have a velocity of movement. Is that not so? You accelerate by pressing down on the throttle, the vehicle speeds up, velocity increases. Are you getting me right? As time is counting, you'll be getting certain velocities over time. Am I communicating? So what is the initial velocity of this motion? According to the question, look at your question. Is the initial velocity u or v? U, is that not so? And remember that the graph is increasing from down up, true or false? Like the vertical axis now, starting from the origin 0 is increasing upward, true or false? So the starting velocity is what we said? U. Is it v? No. V will be what? The starting velocity or the ending velocity? The what? Which we call the final velocity. So with this information, at least, this should tell you that for the graph here, for the one that will be correct, the initial velocity u will be below. Is that not so? Yes. While the final will be what? Up. So u will be below on the vertical axis and v will be what? On top. Is that clear? Is that clear? On the basis of this thing I've told you, there are some graphs you will now quickly eliminate. Are you getting me right? Those ones, you can't consider them as part of your answer. For example, option E. Oh no, where is it? Option A. Do you think you have to think about it? No, because the final velocity is what you have below here. It makes no sense. It started with initial velocity. So the graphs you should be looking at, look at option D. Do you think you have to consider it? No. We are left to option C, B, and what? E. But now look at something. Were we told that the car started from rest? Did they tell us that? No. They didn't tell us that the body started from rest. If they had said that the body started from rest, we could have maybe likely said, okay, it got to a point. You know, from rest means that the initial velocity will be what? 0. Are you following, right? There was no description here that the body started from rest, then reached a certain velocity and still increased that velocity again. No statement like that here. Are you getting me right? Therefore, we shouldn't be thinking of this graph. Look at this graph. The interpretation of this graph is that it started from rest, increased to a particular velocity, and then speed up again. Are you getting me right? I'll give you an instance. Assuming that maybe we start a car. The car was parked, so originally it is at rest. So the initial velocity will be 0. Are you following, right? And then, as you start moving, you know, it will move a bit. The velocity will start increasing, right? When the velocity increases up to a point, like from here, it starts from rest. You now decide to increase the velocity by pressing the throttle small. Are you getting me? The speed increase. Now, if you press the throttle further, what will happen to the speed more? It will move more. Is that not so? That will be described by this. Are you getting me right? But what I'm trying to say is that there was no statement here that the car started from rest. We only told that a body with an initial velocity of what? U. Which means the starting velocity is what? U. So the point where it started with 0 increase before you now see the U. It makes no sense. Are you following, right? It makes no what? Sense. Look at this option E. Please, option C, look at it. Option C. You have something of this kind as well too. Because at this point, I've told you you have to eliminate this option, and I've told you the reason. This thing means it started from rest, moved to a point, got initial velocity, and then changed it again. Are you getting me to final velocity? That's not what is described here according to the question. Look at this one. This one could make a little sense, but look at where they took the initial velocity to. It's not from beginning. Are you getting me right? The question here is very simple and straightforward. A body with an initial velocity of what? U. So it means that the starting point, we are saying that the initial velocity in that case is going to be what? U. And I think that brings us to this what? Are you following right? Option E. Option what? E is the correct answer. Is that clear? Now, what made this graph non-uniform? Non-uniform because the graph is a curve. Are you following? We are not told that the thing started from rest. Since we were not told that it started from rest, there is no way we could say, okay, start from 0 and then up to a point before having a given initial velocity. No. We are told that it has an initial velocity of what? U. So immediately from the beginning there in the graph, we say it has an initial velocity of what? U. Are you following right? So option E defines that for us. That is that, and I guess we have revised some things. Are you following, right? On the basis of what we've treated. Now let us move on to our main work for today's class. Let us move on to our main work for today's class. Are you following? We are going to look at equations of motion. That is what our class is based on. Please be fast in your sketch. I'm going to wipe it now. We've been able to solve questions from velocity time graph, true or false. And we've been able to answer non-calculation questions from velocity time graph. What we just had were velocities, and then we analyzed that. As we had graphs, and then we analyzed the graph. Let us move on to the business of today's class. Equations of uniformly accelerated motion. It is still under translational motion. I am wiping. People like spend 1,000 hours. All right. Equations of uniformly accelerated motion, or simply equation of motion. Uniformly accelerated motion. I've told you, whenever you are sketching something, be fast. Some of you are asked to sketch. You'll be drawing some artistic stuff as if you are going to sell it. You don't do that. Be fast, draw something. Just get the outline. Are you getting me right? Equation of uniformly accelerated motion. Equation of uniformly accelerated motion. Are you in this class? Are you in this class? Remove that thing from your head. All right, please, let's get to business. When talking about the equations of motion, or equations of uniformly accelerated motion, as you might choose to call it, there, we take acceleration to be constant. We take acceleration to be what? Constant. I have a reason why I'm telling you this. There is this part of motion that brings in calculus. At least I've opened your eyes a little to read previously, where I brought in the concept of differentiation. Do you still remember that? But at this level, we don't dive into it much. And that is why I won't dive into it much as well too. I'm saying this because of our use of this word, uniformly accelerated motion. And I told you that in this case, acceleration is considered to be what? Constant. That part where you bring in calculus, you meet it in your 100 level. You are still in your O level works. Are you getting me right? Good. In that case, acceleration varies. That's why you do differentiation. We're not talking about that. I've opened your eyes a bit to some of them. Is that not so? Now, let us focus on where acceleration is constant. Because in that case, where you apply calculus, acceleration, and velocity, you can have cases where they are not constant. They can change. We talk about instantaneous values. Do you still remember when we defined that? Instantaneous velocity, instantaneous acceleration. There, velocity and acceleration can do what? Change, vary. Here we are looking at these quantities as being constant, especially acceleration. Is that okay? Please write. In the case of equations of uniformly accelerated motion, in the case of equations of uniformly accelerated motion, in the case of equations of uniformly accelerated motion, acceleration is constant. Acceleration is what? Constant. Acceleration is constant. Full stop. So in this case, there will be nothing like average acceleration, instantaneous acceleration. Are you getting me? We simply refer to it as what? Acceleration. In 100 level, like I said, we usually differentiate between average acceleration and what? Instantaneous. Average will be that which you do V2 minus V1 over T2 minus T1. Are you getting me right? And instantaneous is the one you do dV over dt. That is dV dt. You differentiate velocity with respect to time. But at this level, we are not going to talk about that. We don't go deep. And whenever you're dealing with this part of equations of motion, you are not bringing in calculus. Are you getting me? You don't differentiate between instantaneous values and average values. You don't do that. Simply use a constant value for them. Are we getting the point? Are we getting it? Good. Now, we are going to look at these equations of motion. We're going to look at these equations of what? Motion. There are three major equations of motion. They are derivable. You can derive them. But I won't go into the derivation fully. Are you getting me right? We have video lessons where I did the full derivation. For anyone going for WAEC, are you getting me right? NECO and the rest, it might be tested on the derivation. In JAMB situation, you don't derive anything. Am I communicating? Now, at the end of today's class, I'll drop the video lesson link. Are you getting me? For you to revise this thing. You can go through the derivation. It's there under physics, JAMB WAEC physics playlist. So let us state the equations of motion without wasting time. These equations of motion, when you are learning them, you learn them in order. You learn them in what? You must know your first equation of motion. You must know your second equation of motion. You must know your third equation of motion. Favor, what did I just say? What did I just say? I am going to punish you. Be careful. Be very careful. Now, the time that you have sat there is enough. Change that position now. Change that position. Do that right away. Be fast before I punish you. I've been observing you. You lost focus somehow in the class. I didn't like that. That's why I didn't want you to sit at that. You can't be sitting across the distance. Each of you have a table. You sit to face the board. But because we are treating graphical work in your master, that's why I allowed that, so you can see some things. At the end of the class, discuss with somebody, at least one among the student occupying the first and second row. Are you getting me right? So if they can make adjustments for you, they can consider you. You sit there. Because I know that place you're sitting now, might start complaining of, say, your eyesight. Like I said, you cost it. Every time you be running to the back when you have opportunities to sit in front. First equation of motion. Right, please. There are three basic equations of motion. There are three basic equations of what? Motion. There are three basic equations of what? Motion. So we're going to talk about the first equation of motion, the second equation of motion, and the what? Third equation of motion. Then I'll give you one other equation of motion. I'll be two other equations of motion. I'll give them to you. But anytime you hear equations of motion, there are three of them. But honestly, whenever you go deep into equations of motion, there are these two extra hidden equations. Am I communicating? We use them to solve problems under motion as well too. But we don't classify them among the equations of motion. The first equation of motion we want to write. First equation of motion. First equation of motion. First equation of motion. That first equation of motion is obtained from the definition of acceleration. Now, who can remind us of the formula of acceleration? Who can remind us of the formula of acceleration? Who can remind us of the formula of acceleration? Who can remind us of the formula of acceleration? Who can remind us of the formula of acceleration? Because that is where we get no chorus answer, young man. Chinedu, no chorus answer. I ask who can remind us of the equations of motion. You raise up hand and us in the equation of acceleration. Yes, Chijoke. Velocity over time is just the general equation. Are you following? Right? Anytime you hear of acceleration is velocity over time, you are correct. But I want that one that respects certain things about velocities, you know. Are you getting me? There is this unique one that I gave to you. In fact, I labeled it as a particular equation number. Are you following, right? Yes? Emmanuel 2, you want to say, it's Emmanuel 1 rather. You are not talking. Be audible. Change in velocity over change in time. Yeah, you are correct in saying change in velocity over change in time. Now, when you talk about the change, how does the formula look like? No chorus answer. You have attempted. Let's give room to somebody else. Yes. Let's hear from you, Chika. V2 minus V1 over time. Thank you. You are correct. However, there is still this one I am looking for again. Yes, all of you are correct in your formulas, but there's this particular one I am looking for, which we can use to establish this formula. Yes, let's hear from you, Precious. V minus U over T. Do you have that formula in your note? Do you have it in your note? Good. So from that formula that acceleration is equal to V minus U over what? T. You can cross multiply and make the V subject of the formula. You've been taught subject of formula in mathematics very well, is that not so? So if I have A equal to V minus U over T, can't you make V subject of the formula? First of all, you cross multiply because what you are looking for is in fraction form, true or false. If you cross multiply, you have V minus U equal to what? AT. Let's work it with the network of our brain. Now, if I have V minus U equal to AT, and I want V to stand alone as subject of the formula, what will you do?
V equals to AT over minus U.
V equal to AT over minus U. Remember what we have? V minus U. V minus U equal to AT. So yes. Divine, let's hear from you. V equal to 80 over U. Does anyone still have something to say? Yes. Chika, let's hear from you. Correct. Why are you saying over? Is U a coefficient of V? You have come back, right? Under plus and minus, do you do divide both sides by coefficient of anything? No. Remember what you have here, like I said, is V minus U equal to AT. So to make this subject of formula, now what do? Move minus U to the right hand side. Is that not so? And if minus is crossing, what happens to it? So that equation you will get V equal to U will go there. Let us write the U first. And then what? Plus AT. That is our first equation of motion. Cram this thing. Cram. You see, sometimes I try to be too raw in certain concepts of necessity when it comes to the things you are meant to know. Are you getting me right? This is a formula, a scientific formula. That is not, I have shown you how we got the formula. Are you getting me right? From definition of acceleration. The next thing is to memorize it. Put it in your brain. And always remember that this equation on the board is called the first equation of motion. It's called what?
The first equation of motion.
So, dear friends, please, can we state the first equation of motion? Let us go. Will you forget it? Will you forget it? Let us go to the second equation of motion. But before the second equation of motion, I would like us to calm down and look at the parameters, the quantities in this formula. What is the meaning of this V? Now, which velocity? Final velocity. Please write it in your notes because you should know the meaning of each of those terms. You know, in any scientific formula, you must know the meaning of the quantities. Are you getting me right? Where V is equal to final velocity. What's the meaning of U? Initial velocity. What's the meaning of A? Acceleration. What is the meaning of T? You are very correct. And you know that an equation, a formula can be used to calculate any of the quantities you have inside the formula, true or false. So you see this formula, you can use it to find V, final velocity, you can use it to find U, initial velocity, you can use it to find A, acceleration, you can use it to calculate the time of a given motion. Are you getting me right? It all depends on the values given to you in the question. Now I have one question for you. I have what? One question for you. Are you ready for my question? Look at this first equation of motion. Can you use this first equation of motion to find distance? Distance. Can you use this first equation of motion to find distance? Please take note of, don't talk anything anyhow. Don't say anything anyhow. Remember, I told you something just now. I have not even taken time. When you are given a mathematical equation, that you can use that equation to calculate any of the thing inside that what? Is that not so? If you are given a formula, you can use that formula to find the value of anything inside that formula. Is that not so? So I have this question to you. Don't waste my time. This is not a question to waste time. It's not a question. It's a yes or no question. Can you use this formula to calculate distance? Yes or no? No. Those that are saying yes, where did you see distance in this thing? Where did you see distance? Am I communicating? Yes. You see, I am training you people very well today, because sometimes when it comes to using scientific formulas, some person will be thinking, what are you thinking of? Some of you are so funny that you would go and use a formula to solve a particular quantity that is not in that formula. And you'd be like, how? Imagine somebody using this formula. You want to say you find force. In example, you start cracking your brain. In the question, you say calculate force. And then you now say that the formula that will solve the force, V equal to U plus 80. Are you serious? Where in the world, in this world, will you find force in this formula that made you to start thinking of this formula? So you want to know things about mathematical formulas, scientific formulas, why we use them, and what we can use them to look for, to solve. Am I communicating? You can only use this guy to find either final velocity or initial velocity or acceleration or what? Time. You can't use it to find any other physical quantity. Am I communicating? Yes. I mean, using it directly to calculate, okay, find distance. You now say V equal to U plus 80. Oh yeah, tell me the quantity that is distance here. I hope it's clear, right? Yes. That's good, dear friends. Let's move on to the second equation of motion. Second equation of motion. Like I said, these equations are derivable. However, it's I'm sorry, I wouldn't be sorry about that. You know that the GMAETS 41 Special Science College transcends just physical class. Are you getting me right? I teach you these things. There are certain things I'll tell you, okay, learn them. Are you following, right? I'll just drop the link. So in the derivation, learn the derivation. You have a video lesson, you would take it over and over again to understand all of those principles. Are you following, right? Do substitution, do this, do that, and things like that. Let's move on to the second equation of motion. Second equation of what? Motion. What does the equation look like? It's given as S equal to UT plus 1 over 2 AT squared. Equation 2. This is the second equation of motion. You see, funny enough, your examiner can ask you a question as simple and straightforward as this. Which of the following is first equation of motion? Which of the following is third equation of motion? You see the reason why I told you must learn it in order. You don't have a choice. This is not the formula you learn by scattering them. Oh, you can just say any one of them anyhow. No. Know that this one is first equation of motion. The other is second. And that is what? Third equation of motion. You should know that. This is your second equation of motion. S equal to UT plus 1 over 2 AT squared. Are you following, right? Every other quantity has its usual meaning as you learn from here. The only thing we need to define here now is S. Is that not so? Yes. So let me write where S is equal to what? Distance. Am I communicating? Are you learning? Yes. All right. A formula can be used to calculate, to solve, to find, to resolve, to get the value of any quantity that is contained in that formula. Are you getting me? Any quantity that is not inside that formula, you can't use that formula to solve it. You can't use that formula directly to get a quantity that is not contained in the formula. Are we together? Look at this equation of motion. Don't scatter them. You see that this thing is given in order. Is that not so? Tell me the quantities you can use this formula to calculate first. Correct? I say don't scatter. You have mentioned time. Why will you go and jump from there? Even if you can tell me any one that can be calculated, from there. I want us to follow in order so that our response will be uniform. Are you getting me right? Okay, the first thing you can use this equation to find. I will strike your head now with my marker. I give you another opportunity. What quantities can you use this formula to calculate? Distance. Now, initial velocity. You know, when you just say velocity like that, you might be thinking that you use this thing for final velocity. You don't. Am I communicating right? You use this formula to find initial velocity. You don't use it to find V. Are you getting me right? Another quantity you can use this formula to calculate. Another formula you can use this quantity to calculate. Correct. You still have time there. Time is time. Are you getting me? So those 4 quantities. Now I have this question for you. You are exposed to a particular motion problem. Are you getting me right? And you are asked to find the final velocity of the body, of the particle, of the object. Are we together? Find the what I said. Final velocity. Will you think of this formula? No. So be guided. Are you getting me? There is no final velocity here. So you can't use this to find final velocity directly. Except if that question requires that you have to get one thing first before you use it to get another. Are you getting me right? There are some kind of questions that can be presented like that. I'll give you an instance. Can you use this formula to calculate distance? No. But let me assume I give you a question and I say you should find distance. I said you should find what? Distance. But you don't know initial velocity. You don't know what? Please, dear friends, look at this equation 2. If you must know the value of these distances in equation 2, do you need the value of initial velocity or not? Do you need it or not? You need it, is that not so? But now I give you a question. I'm asking you, find the distance. But unfortunately, in the body of the question, you do not have initial velocity. You don't have what? Let me assume you have time. You have acceleration, but you don't have initial velocity. And you were not told that the motion started from rest. You were not told that the motion started from what? Rest. Are you getting me? You know time, you know acceleration. You were not told that the velocity, the motion started from rest. You weren't. But they gave you final velocity. They gave you what? That is, they gave you T, they gave you A, they gave you V. You know this guy, you know this guy, you know this guy. They say you should find distance. Am I communicating? If I tell you to find distance, and these are the values I gave to you, you know you will start thinking of this formula, is that not so, to find distance? But with these values given, do you think that this formula is now ready to solve the question? Why is the formula not ready yet? Speak, let me hear you. No initial velocity. Are you getting me right? Now, in this case, this is what you will do in that question. Since you know T, you know A, you know V. Are you getting me right? Look at equation 1. Look at equation 1. You know V. Are you getting me right? You know the value of A. Am I communicating? You know the value of T. Am I passing any information? So do you see, you know how many things from this formula? 3 things. Remaining, how many? Only 1. And you know you use a formula to solve a question when you know everything in that question except one thing. I have told you this before, isn't it? On several occasions. Don't you see that you are looking for my trouble, favor? Don't you see? You are here to learn, not to lie down. You want me to administer punishments to you before you put yourself together? You said? You weren't looking at the board. You weren't looking at the board. You were lying your head down. True or false? Who is telling lies? Did I see you lying your head down? Of course, I paused the class for a moment because of seeing you not being in a learning mood. I've warned you people, listen, there is a way you sit in class. Emmanuel, sit properly. You sit down as if you're in your parlor. What's the problem? There is a way a student sits. You are not allowed to lie down like this. When you're you don't do all those things. Before you know, your body cells will become too relaxed and you will just doze off. Be active. You can do this. I'm not happy with you, Favor. You can still make me happy. I complained about you from there. You had to switch your position to sit properly, and you still went there and you were lying like this. Didn't you sleep yesterday night? You didn't sleep well? Huh? Please, you are here to learn. And remember, you have a professional exam you are preparing for. I've told you it's not funny. Your work, your job is not. Forget the nonsense happening in this country, Nigeria. Let's just forget it. The way people are messing up when it comes to professional exams. Forget it. Individually, you want to always be at alert. Listen, no matter how they are messing up, even the exam body sometimes will do certain things or whatever. Some parents will come and say, we just want our child to pass, whatever. Listen, I'm not that kind of person. I will never be involved in wanting you to pass by fire, by force. You should merit it to pass. I've said this time and again. Are you getting me right? You should merit it to pass. You see me when I vibrate in class. After physical class, I meet you online again. I have other things I'm doing. Do you think it's because I have the most power? Our God and helper gives me this strength. The only reason is because he sees my determination to ensure that I help future generations. Remember that whatever you do today, the consequence is there awaiting you. You hear today a lot of people just complaining Nigeria is this. Yeah, Nigeria has its own problem, challenges, yes. As much as we cannot be blind to the fact that the challenge is all around the world now. These are prophecies fulfilling as Bible puts it. If you talk about insecurity, let's assume say in the country or world, do you think it's only Nigeria that they have insecurity? I think the only problem why we complain sometimes that these things are happening and it's as if things, as in measures are not being put in place to solve as in to try to tackle some of these things. You talk of difficulty, surviving. High cost of things. Do you think it's only in Nigeria? It's almost everywhere in the world. Look at developed countries. You talk of the UK, the US, you see their citizens complaining there is no job for them, this and that. Every time, maybe one protest or the other. Are you getting me? You hear of some country, they'll tell you, no, we want these people to leave our country, go back to their country. They have collected all the jobs. I think something like that happened. Was it in South Africa sometimes recently? Is that not so? In Ghana recently, there was a protest against Nigerians. True or false? Listen, work hard. You have decided to choose a path of going to school, of studying. This is your own life. Do the best thing. When you are being taught, be active. From the hour of 9:30 to 2 o'clock, we have our class. We still have break interval. I mean, it's not much now, isn't it? It's not. Whenever you're coming to class, have it in mind you are here for something. I will start administering punishment seriously again. Take note. You are not just kids of primary school that can't be punished when necessary. So you wake up. Sometimes when we overlook these things, this is how you just be misbehaving, and it's not good for you. It's not. Please, I'm saying this out of my love for you, friends. I want the best for you. Hey, I am made. I have attained that level. I feel like I can survive anywhere in this world. Whatever this country throws at me, I don't care. And I want to do that for some other people as well too. Why some people complain, they are teachers, they are complaining, hey, in teaching in this, I don't complain. I've said this time and again. As a teacher, I don't complain. There are various ways I can survive as a teacher. People will look for me. It's not because I am the best in everything I do per se. I know I am good. I am best in a lot of areas. But come on, there are still many people very good at what they do. It is the mindset. Am I communicating, right? The determination. I want to achieve and attain this height. And everybody can do it if someone has done it before. Please. Please. Let's go back to what we are dealing with, please. I said the question is given to you. You are asked to find what? Distance. But in that question, you are given time, acceleration, final velocity. But you know to calculate distance, normally using the equation of motion, this is what you need. Are you getting me right? The motion did not start from rest. If a motion did not start, or if a motion does not start from rest, will you say that u is 0? But if it starts from rest, U will be what? We've talked about that in our part 1 class on motion. So in this case, it is not 0. That's what I'm saying, because nobody told you it started from rest. Are you following? And in fact, they gave you final velocity. So what do? You can't use this to calculate distance directly in that case. Are you getting me right? Because if you apply this formula directly, you will get into trouble somewhere. And where will you get into trouble? You don't know U. Is that not so? So what do you do in that case? You use this equation now. You know your V. You know your A. You know your T. The only thing you don't know is what? U. Are you following right? So since you know your TAV, substitute it in equation 1. Remember, what they ask you to find is distance. Am I communicating right? And you know you don't use this thing to calculate distance. It has nothing to do with distance. But you need to use this equation to get what? U in that case. Are you getting me right? Let me assume that time is 2 seconds. Acceleration is 5 meters per square second. And say final velocity is 1 meter per second. Use this data to find initial velocity. Then once you get initial velocity, you can now bring it back to this distance formula. You know what took us to my explaining this, right? You should know when to use a particular formula. You don't use a formula to calculate something that the formula does not contain. However, there are times in which you cannot use a particular formula directly to solve what it contains. Are you getting me right? Like this example I gave. This is used for distance specifically. But there are some questions that might be given to you. You cannot use it directly to find distance. You may need to go through somewhere. Are you getting me right? Get something you need. I've just used you as an example. Are you following? After you get it, you come back and do what? Substitute. Anyway, don't worry when it is time for calculations, okay? I've given you the second equation of motion. Now, once again, can you use this equation to calculate final velocity? No. Please, dear friends, it's very important for you to know how to use formula. That is what defines science for you. Engineering, medicine field, environmental sciences, biological sciences, physical sciences, you must be good with the use of all these formula stuff. This is academics. Are you getting me right? There are standards set for you to follow. Now we are moving on to the third equation of motion. Third equation of motion. Third equation of motion. The third equation of motion is given as square of V equal to square of U, then plus 2AS. This is the third equation of motion. Square of V, square of U. Square of V equal to square of U plus 2 times acceleration times distance S. All the quantities we have there have their usual meaning. Are you getting me right? All the quantities we have there, they make use of their usual what? Meaning. You see, we are moving into parts of science where you don't need to lazy around. If you check your past questions, you will see works on that. When you talk of motion, this is actually where motion really begins when it comes to asking exam questions that are calculation related. That is why you see, I am telling you, please be active, be awake. Are you getting me? Be focused. It makes no sense that at the end of all the stress, are you getting? You go through stress and other things, and result does not speak for it. I want to break record for us. You know, last set we were able to hit 350. What if somebody decide to drop 400 or 400? It's possible. All right, let us move on, please. Are you getting me? Now, I don't need to define anything here anymore because all of them have their usual meaning. But I have a question for you again. Are you ready? Which quantities can we use this formula to calculate? Don't scatter them. Tell me the quantities in order. Let's go.
Final velocity, initial velocity, acceleration.
Question. Can you use the third equation of motion to calculate time? Why? It does not contain time. These are the three equations of motion. Whenever you hear, state the three equations of motion. This is the first equation. This is the second and this is the third. Can we please read over them together? The first equation of motion, let us go. V U plus AT. Second equation of motion, S equal to UT plus 1 over 2 AT squared. Third equation of motion, V squared equal to U squared plus 2AS. Before you step out of this class today, before we dismiss by 2, you are expected to have known these formulas at heart. You can do it. And when you are going back to your various homes, what is there in your mind? Thank God that God has created us with a lot of wonders as gifts in us. You don't need your book to read or remind yourself of this formula. Before leaving, you can be recapping them. Are you following? V equal to U plus AT. S equal to UT plus half AT squared. V squared equal to U squared plus 2AS. Because whether I like it or not, you must see question on this guy in your exams. Am I communicating? And in 100 level, you will still meet it. In 100 level, you meet these equations of motion. Am I communicating? Good. Now, there are these two other equations that we do not consider as pure equations of motion, but they are also equations under motion. Are you getting me right? So note the following equations, please. Note. When we are deriving these guys, we also make use of these two equations I'm about to give. One of them is in terms of average velocity. Are you getting me? Average velocity. How does the equation look like under motion when you're talking about average velocity? Before I give you that equation, let me ask you, please. Are you ready? Are you ready? The average of anything, how do you get it? Add up everything, divide by the number of item or observation. Is that not so? Statistics in maths, data gathering and interpretation tells us about that mean, the concept of mean model. Good. Now you observe that there are these two velocities we had always encountered. True or false? Mention the velocities. Initial and final. So you can get their average. You can do what? Get their average. So can we find average velocity in this case? So the first one, right, please. Average velocity. Average velocity. Permit me to use I and II for them. Average velocity. Average velocity, I am going to use V bar for it. I'm going to use what? V bar. It is the sum. Look at it. V bar. It's pronounced V bar. It is the sum of the two main velocities divided by 2. So this is equal to initial velocity plus final velocity divided by what? 2. You want to take note of this equation. Let me call it equation 4. But remember, there are 3 basic equations of motion. Is that not so? Yes. Good. But we shall take this as equation 4. It's not among the main equations of motion. Let me expose somebody to you friends in the class today. This person has been battling. She has been fighting. Say, hide, God, sleep, don't do this to me. Chioma. For more than 1 hour now, you've been battling with sleep. You didn't sleep yesterday night. So why will you come to class and you still be feeling sleepy? What time did you sleep yesterday night? You are scared of answering the question now. Around 11. But that is sufficient. Normal sleeping hour is 8 hours. Normal sleeping hours. 6, 8. It's sufficient now. You're not meant to be sleeping in class. See, sleeping in class, lying down in class is a bad habit. And I'll tell you, when perhaps if you land yourself a job, you get a job, you go to office, you start sleeping. Your boss will just come. They'll just drop letter on top of your table and leave. Tomorrow, let them see you in the vicinity of that office again. What will be inside the letter? You know the information will be contained. What will be contained in it? We no longer need your service. Because we found out that when you were in school, you were busy sleeping when your teacher is teaching. And your teacher was complaining that time. Now, we have decided to give you a job. We want to run our company down. Leave, we don't need you again. Of course, many people are looking for jobs. So it's a bad habit. There is time for everything. Even the Bible says so in Ecclesiastes. Now, the second equation. So she's been battling it. You tried, keep battling, then open your eyes. Right? If it is difficult, look for blue. All right, it's not easy, okay? You guys, you're trying, okay? Keep it up, keep putting on the effort. And it's not easy, but you can do it because people are doing it. Now, the next equation, which is not considered purely among the equations of motion, but we also make use of them under motion, is that which we obtain from the definition of speed. What is the definition of speed? Because we've treated that part of motion. That is part one of motion. Distance over time, is that not so? Speed is distance over time. And we use V for speed also, true or false? Yes. Now, if speed is equal to distance over time, and I tell you to make distance subject of the formula. I tell you to make distance subject of the what? Formula. I crack your brain now. Speed is distance over time. So, making distance subject of formula, what would the formula be? Distance will be what? Speed times time. That speed there is usually average speed. It's average what? So our distance, let me use S, is equal to average speed times time. And there we use average velocity. We use what? Average velocity times time. We use average velocity times what? Time. That speed there, we replace it with average velocity. I've told you before now that there are certain cases that speed and velocity will be the same. Are you getting me right? These two motion quantities. I always say in a first step motion, are you getting me? A one-step movement like this, speed and velocity, they will have the same value. Because in a one-step motion, distance and displacement, they also have the same value. I demonstrated it when I taught you part one of motion. The only time you differentiate between distance and displacement is when you take multiple motion in different direction. If I move from here to here, this is one step motion. I now turn, move again. Is this still one step motion altogether? No, it is a two-step motion. That is the only case one can now start differentiating between distance and displacement classically. Otherwise, in just one step motion, distance and displacement, they have the same value. That is why at this level, even in 100 level per se, most times when questions are given, something that has to do with displacement or distance, we use them interchangeably. Are you getting me? And in that context also, speed and velocity are used interchangeably, even though we know they are not exactly the same. For you to know their difference, take multiple motion in different directions. Then again, if you come to scalars and vectors, we'll tell you that distance is scalar. Displacement is what? Vector. Speed is what? Scalar. Good. Velocity is what? Vector. So use scalars and vector to differentiate. But in terms of real life interpretation, are you getting me right? If you want to differentiate between distance and displacement and hence speed and velocity, you take multiple motion. But coming here, the velocity we use here is average velocity. And we already have average velocity here, true or false? Can you now do substitution if you want? You know, I can remove this average velocity and put what? U plus V over 2. Let me show it somewhere here. Because when you take that video lesson, are you following on the derivation? How we derive this equation of motion? Equation 1, there is no special derivation to it. It uses definition of acceleration. V equal to U plus AT. Remember, we got it from A equal to V minus U all over T. Cross multiply, then collect terms. Are you following, right? So that one, there is no special derivation. That's very simple. But you see this second guy, this second equation of motion and third equation of motion, it makes a special formulas to derive them. These two formulas, we apply them in the process. Are you getting me right? Like this particular one now. This S equal to average velocity times time. Where you will remove average velocity and fix this guy. Are you getting me right? So you get S equal to U plus V in brackets divided by 2 then times what? T. You use it to derive this equation. Are you getting me right? Use to derive this equation. Then to derive this equation along the line, I think we use this guy also to this one specifically. Is that okay? We use it. I'm saying this out when you meet it in the derivation, especially those that are going to take WAEC, because you need to know the derivation, you can actually grasp what I am explaining there. If you fix that, your distance will be equal to average velocity. And what's the value of average velocity? U plus V over what? 2. Multiplied by what? Time. Is that clear? So we are done with the equations of motion, please. And we are done with this part of motion. All that is left is just the calculation. Please, if you have any question, you can ask. If you have any question, you can ask. Of course, you know that here at GMAETS 41 Special Science College, question is something we love a lot. Are you getting me right? Because when you don't understand something, you need to ask so that the point will be made even much more clearer. I will take your silence to mean that you know about these equations of motion, like you understand what we have done here already. Like I said, it's just for you to memorize those equations of motion. Are you getting me right? Put them here. There are 3 of them. Then add up this one, because sometimes there are questions they might give to you that will need you to use these equations. Just think of this. If I tell you that, what are you still writing? Have you not finished? Okay, pay attention, please. I want to say something. If I tell you that a car moves with a velocity of 20 meters per second and then increase the velocity to 50 meters per second, calculate the average velocity. I repeat the statement. A car moves with a velocity of what? 20 meters per second and then increased to what? 50 meters per second. With the values I gave you, they represent what? Initial and final velocity. Is that not so? The initial is what? 20 what? The final is what? Good. And now say find average velocity. All you do is just to eat your rice and your indomie. You know, you guys like rice and indomie. But me, I will eat swallow. And then I'll smile and blast the question. I'll just simply do 20 plus 50 divided by what? 2. Very simple now. Is that not so? Okay, now, that is where you bring in this. Are you getting me right? Yes. Now, think of this. An examiner gives you a question. Oh, God. Chijioke. You guys will not stop amazing me. Chijioke, come here. Come. You know you are my boy. But you disturb me a lot. Raise your left hand. Raise it for the friends, your friends to see. Raise it. Look at what Chijioke is busy doing to his finger. I know the world is seeing you now. The world is seeing you. Are you supposed to be doing this? You shouldn't be making me angry. You know I like you so much and I want the best for you. In fact, I want you to be the image of GMAETS for the one special science college. Yes. You are the only person I can think of being the image, not these ones. These ones will soon leave. They are approaching their exam. Almost all of them are taking their professional exams. Is that not so? Don't do all these things. Go and sit down. And besides, you've just messed up your fingers. All right. Listen to this next question. A car moves, or a particle, a body, whatever they want to use. Are you following, right? Moves with an average velocity of 5 meters per second, or moves with a velocity of 5 meters per second in 2 seconds. I repeat, a body moves with a velocity, or I say with an average velocity. The choice is mine, whether I want to specify it as average velocity or not. A body moves with a velocity, or with an average velocity of 5 meters per second. Are you there? In 2 seconds. Did you get the parameter, the quantity I gave there? What and what did I give you? 5 meters per second is what?
Average.
Is velocity. This time. 5 meters per second. You see why I told you you don't joke with quantities and their units. Okay, and I said that this velocity, the body moves with this velocity in 2 seconds. That 2 seconds represent what? Time. So you know the quantities I gave you, is that not so? Calculate the distance covered by the body, by the particle, by the object, by the car, by whomever. It could be by Chukwuka. Right? It could be by Emmanuel, by Goodluck, it could be by Chinedu, it could be by anybody here. It could be by this board. If I say, okay, let us learn, it's falling, right? So anything can be used to ask you a question as something that is being moved in motion. Am I communicating? Good. So you know the parameters, right? I'm now asking you calculate the distance. Which formula would you use? Is that not so? You simply do what times what. So what's the value of the distance covered there? 10. 10 what? Meters. Correct. All right. Are we good to go? Let's solve some question. We're going to look at this question from JAMB. You see, most of the questions you have in the JAMB past question that you friends have, there are other things. And the WAEC, not of WAEC, because open to motion part in WAEC, I was going to solve questions from there. Most of them are about equations of motion. Equations of motion along a straight line, which is what we are treating now. Or equation of motion under gravity. You know, this one is horizontal motion. Following, right? If it is gravity, that one is vertical. That's our next topic in physics. Am I communicating? There, A will change to G. A will change to what? G. Acceleration due to gravity. These things are 1 plus 1. Once you are coached and coached very well, you will love it. You have your physics WAEC question paper there, right? Good. So open to motion. I've got this question. We're just going to solve like 2-3 questions. And of course, our time would have been up. Are we ready? Are we ready? So let me wipe this, and then I'll copy this question on the board. My duster has gone backward when I wanted the board to exhibit motion. All right. So we've got this question, and I'll write it on the board. Question 1. This is JAMB 1988. Now I have a question for you. JAMB 1988. Does it now mean that this question we are going to deal with is now irrelevant? Hey, it is for many, many years. 1988, then they have not even given birth to you, you know. Is that true? You still need it. This is science. It doesn't change significantly over time. And this is the question. I'm saying this so that you'll be aware that the year of a particular question does not really make any real difference. Are you following? A particle starts from rest. A particle starts from rest. A particle starts from rest and moves with a constant acceleration. And moves with a constant acceleration. If you have your past question, this question I am dictating it from page 12 of that your past question. Have you seen it? Page 12. That is actually question 7 of that page 12. But according to our own question numbering, this is our first question under this part of motion. Page 12, number 7. Have you seen it? Good. Constant acceleration, and moves with the constant acceleration of 0.5 meter per square second. The distance covered by the particle in 10 seconds in 10 seconds is, so we don't know the distance covered by the particle in 10 seconds. Now let me write the options, even though most times I don't like writing out the options, because you should not be bothered by, say, options in solving questions. You should know how to handle it. Are you getting me right? And once you solve it correctly, definitely one of the answers must be there. If it is not there and you're 100% sure that you did the right thing, it means the question is not wrong. It's not correct, rather, or the option is not there per se. That is why most times I don't like even bringing out options, but let me bring out the options here. 2.5 meter. Option B is 5.0 meter. Option D is 25.0 meter. Is it option D or C? And then option D is 50.0 meter. These are the options given to us. Is that? You've solved it. That's sharp. That's sharp. Okay, let us hear from you. Chika says she has solved it. What did you get? 50.0 meter. All right, let's see. We are going to work it together. Are you following, right? And see. And I must assure you, dear friends, that this question is 1 plus 1. Have you copied it? Have you copied it? If you have copied it, then let us write solution, being prepared to now solve. Let's look at the question very well. Are we there? We are told that a particle starts from where? Rest. When you are told that a particle, a motion starts from rest, what is the implication? Initial velocity is what? 0. So we know that u is equal to 0 for this question. And moves with a constant acceleration of 0.5 meter per square second. Now, question. This 0.5 meter per square second represents which quantity? Acceleration. Even if you cannot correlate the grammar from here that this is acceleration. Remember, that's why I told you the unit. You don't joke with unit. Are you getting me right? But of course, if you look at the grammar, you know that this is acceleration. However, there are some times they will not tell you. They won't use the word, acceleration. But they will write this thing with a unit. The unit is now what will help you. For example, if I say, and moves. And moves. Or let me say, and increase its speed with 0.5 meter per square second. And increased its speed with 0.5 meter per square second. In that my statement, did I say anything about acceleration there? Did I mention acceleration? I said increase the speed with 0.5 meter per square second. Do you know that some persons will go and misinterpret the 0.5 to be speed? They will not be saying velocity, but is that correct? The unit should always tell you, are you getting me right, what the quantity is? That thing that it increased speed with 0.5 meter per square second means the body, the particle accelerated. Because it is acceleration that increases speed. Now, is that not so? Then to give us that value. We go. Now we're going to have A to be equal to 0.5 meter per square second. What are we looking for in this question? So the unknown is distance. You know, I will throw a lot of questions at you. Now, these are the information given to us in the question. We know the initial velocity. Is that not so? 0, because the motion started from rest. We know the acceleration, 0.5. Is that not so? But we don't know distance. Okay, they gave us time. Thank you. T is 10 seconds. So they give us time. Now, what are we looking for? Attention on the board now. There's the time to look at me and look at the board. We are done analyzing what is in your notes. So look at me, look at the board. We are looking for distance. We know U, we know A, we know T. You know, in dealing with equations of motion, you don't just wake up and select any equation anyhow. And you don't have a ready-made equation to a particular question. Oh, you are just reading the equation, you have not even finished, you've not even gotten the idea. You now start thinking of the equation of motion to use. Is it not funny? Don't invent any equation. Read the question, identify the parameters given to you. Are you getting me? Then think of the equations of motion. The equations of motion will be the last thing to think. After you have read the question, brought out the words, the data, are you getting me right? You now ask yourself this question. Look at me. You ask yourself, from these values given to me in this question, and what I am looking for, which equation of motion fits this information? Remember, you can only choose an equation to use in solving a problem when you know everything in that formula except when you know everything in that formula except only one thing. Is that not so? So look at what we have here. Look at what we are looking for, what we are asked to calculate. Now I'm going to ask you questions. Look at your first equation of motion. Look at it. What are we asked to solve here? What are we looking for here? Now look at your first equation of motion. Because I don't just want us to jump into the equation that will solve this. I like us to look at why can't we use this? Are you getting me? Why can't we use this? And then finally, when we select the one we use, you now nod your head and say, yes, we are in line. Can you use the first equation of motion to solve this problem? Why can you not even think about it? We are asked to find distance. Is that not so? Yes. And distance is not contained there. Is that not so? Yes. Now, I will take you to equation 3. Third equation of motion. Look at that equation. Look at that equation. Have you looked at that equation very well? Do you know that equation contains distance? It contains distance. So you can use that equation to solve distance. I hope you know that. Yes, you can use that equation to calculate distance. The question will now be, okay, that equation contains distance. But the data given to me here, does it fit that equation? Do you say yes or no? Can somebody tell me the reason why you say no? No chorus answer. Why do you think the third equation of motion can't fit this? Although S is there, distance is there, but we are saying we can't use it to solve. Yes, let's hear from you, Chijioke. S is not made subject. Well, thank you for the answer, but hey, you know in any equation, it does not matter what is made subject of the formula. You can make that in subject if you want. Are you getting me? All right, I'm very happy. If Favor wants to, she's smart. If you don't want to talk again, you must talk. If you don't talk, then leave my class. You raised up your hand. Did you not? Did you not? I saw your hand. I'm very happy. At least you're part of the class now after several fights with me, you know. I'm happy. Let's hear from you. Why can't you use the third equation of motion here? Even if it contains distance. As long as it contains distance, Chijioke, you can use it to solve. Stop this thing now. What is your problem? You painted your hand. I complained. You are still doing it. Drop your pen here. I might have to have you sit up. Because you hide your hand and you'll be painting your hand. Are you an artist? Favor, please. Pay attention to answers they are given. You have attempted, appreciated, but I did not approve of your answer. Someone wants to give an answer, and you are busy painting, looking and painting your hand. Instead of you paying attention. Please, quickly, help us. Let's see. Why can't you use the third equation of motion? Even though we can use that equation to find distance. Distance is there. We can make a subject and then calculate for distance. But we are saying we can't use it. Why? Time is missing in that equation. Time is missing. And apart from the fact that time is missing, there's another thing that is significant. Let's hear from you, Mrs. Ifezu. Let's hear from you. Correct. That is one of the key reasons. Are you getting me? For you to use that formula to calculate distance, you must know final velocity. Are you getting me right? At least we know initial velocity, we know acceleration. You must know final velocity. Now, Favor, you say that time is not there. Let me tell you, friends, something now. You are correct in that reasoning. However, that is not the major reason why you can't use that formula. Are you getting me right? This is why I made this statement. Let me tell you something about calculation subjects sometimes. There are times an examiner may give you a particular value in a given question. But that value, you don't even need to use it at all. It used to happen. Are you getting me right? I know some students who don't see values with their eyes. Once they see, they want to use it by fire, by force. Sometimes a value might be given to you. You don't need to use it. So like you say, look at this guy. Assuming we knew the final velocity. Are you getting me right? we could have still used equation 3, the third equation of motion, to solve. Because in that case, we know U, we know V, we know A. Only S will not be the problem. Are you getting me? Even if they give us time there, it doesn't matter. Would we have to use time in that equation? No. As long as we know V and U and A, we can use the find distance. So the major reason why we can't use this equation 3, third equation, is because this guy, they didn't give us what? V. Now we are left with which equation of motion, please? We are left with which equation of motion? Good. Tell me second equation of motion, not 2. You use a first equation, second, and third. Okay, so what's the second equation of motion? Good. Now, do you think that equation can solve this problem directly? Yes. Why do you say so? Why did you say yes, it can solve it? Why do you say we can use this to solve for that distance? It contains all the things you are looking for except distance. That is to say, all the quantities, the parameters in that second equation of motion, we know all of them except distance. Does it not satisfy the condition of using the formula? Does it not? Good. Using second equation of motion, S equal to ut plus 1 over 2 at squared. So you see how we analyze this question fully so I will know what to do. It's not just all about jumping and say, I'm teaching you, I give you question, I start solving, and somebody will be looking at, why did he use this equation? You know, that's the problem in this topic. Are you getting me right? Once you are teaching it or you are learning it without making analysis, this is the equation to use. This is why I am using it. This is why I shouldn't think of the other one. You should know about that. Because you are not the one to tell your examiner how to give you the question. Are you getting me right? Now, our U is what? What's the value of U? Now, let me show something. I don't want to substitute directly yet. I don't want to. If U is 0, because motion started from rest, it implies that our S will be equal to, if I fix 0 here, it will become 0 times what? T. 0 times T will give you what? So you now have 0 plus half AT squared. Is that not so? 0 plus anything will give you what? That thing. So can I write this equation as S equal to 1 over 2 AT squared? Can I write it that way? Yes. So get used to this guy. As a matter of fact, there are several questions sometimes that examiners can give with this equation 2. Are you getting me? Once you know that the motion started from where? Rests. Don't punish yourself with that UT anymore. Just use the AT squared part for the distance. Is that clear? Now let us substitute. S will now be equal to 1 over 2 times. What is our acceleration? 0.5. What is our time? 10. You square it. S is now equal to, this is 100. You know, 0.5 is also half. Is that not so? 1 over 2. So that under here you have 4. True or false? Why is it 4? 1 over 2 times 1 over 2. 1 times 1 will give you 1. 2 times 2 will give you 4. 10 square will give you what? 100. Then everything will now be what? What over what? 100 over... And 100 divided by 4 will give you what? 25.0, or simply 25 meter. So Chika, this does not agree with your answer. Where did you make that mistake? Again, louder, let me hear you. You've corrected your mistake, right? Okay. Was this the equation you used? Are you sure? All right. Okay, so the correct option here is option what? C. Any question? Our time is up. This is 4 minutes to 2, so we can take another question again. You know, what we have done here is to establish the principle of the equation of uniformly accelerated motion. Is that not so? Is that not so? Good. On Thursday, we are going to take on physics. We'll have maths and further maths, general maths and further maths that day. Are you getting me right? Huh? Good. I know we are doing a lot of unique works on maths. So this is what is going to happen. We're going to take physics that day as against maths, possibly. You'll get further information about it. Yeah, I want us to finish this part of calculation. Are you getting me right? Before next week. So next week we'll be entering equation of motion under gravity, the vertical one. And let me tell you, equation of motion under gravity, you have learned it. You have what? You have learned it. You have. And somebody will be wondering, what does he mean? You want me to tell you what I mean? Do you want to know that you have learned it? These three equations of uniformly accelerated motion under translational motion, that is horizontal motion. Are you following, right? The three equations of motion, v equal to u plus at, s equal to ut plus half at squared, square root of v equal to square root of u plus 2as. These three equations are the same equation of motion under gravity. The only thing is that A, acceleration, will now be replaced with what? G. Are you getting me? That will now tell you if the motion is going up, it will now become minus G. Like in this case now, it will be minus 1 over 2 gt squared. You still have your ut if the motion is going up. If it is coming down, it will still maintain plus. Are you getting me, right? Then A will be replaced with G. That's just the only thing. So do you see? You know those equations already. Because that day I won't waste time explaining much of this like I did today. We'll set out the foundation. I'll just give you the equations and we'll start blasting questions from your exam question. Did you find one from WAEC? Yes, we have one in WAEC here. So I don't know if I could just solve that, but I'll be very fast. Are you getting me? And I won't copy the question on the board. I will dictate it so you can copy it. Is there any question on this one we solved? Let's be fast. After copying the question in less than 2 minutes, we should be able to get the answer. The 2 minutes is because I might have to explain 1 or 2 things for you. So this is question number 2, the last as we close today. All right. This is question number 2, the last as we close today. Are you there? Okay, so I've got this one. My eyes have just gone to this. This is 1994. Perhaps, can I check if I can find any most recent, but it doesn't matter as to whether it is most recent or not. Does it change anything? All of them are still motion problems. So, but let me just check and see if I can just... Anyway, I think next class we'll still have more than enough time. Are you following, right? Let us look at this question. Let's look at this question. This is question number 2. WASEC, 1994. 1994. The question was still repeated in 2007, according to the information in the class question here. They have that question in 94, they repeated it in 2007. You know, sometimes, I'm not telling you because some of you now, they repeat question. You will swallow past question instead of study first and understand. Are you getting me? Okay, but I am taking, okay, let me say 94/97, slash 2007. Okay, let me copy the question on the board. A body accelerates uniformly from rest. A body accelerates uniformly from rest. You know the implication of that statement from rest already, is that not so? At 2 meters per square second. Full stop. Calculate the magnitude. Calculate the magnitude of its velocity. After traveling 9 meters. After traveling 9 meters. We have options, but I'll just read out the option roughly. I won't write them on the board. When we are done solving, I'll still read it. I will select. Option A, 4.5 meters per second. Option B, 6.0 meters per second. Option C, 18.0 meters per second. Option D, 36.0 meters per second. So let us trash this question quickly. Thank you for giving us the past question here. Are we there? Solution. Now look at this. What are the parameters, the data, the information given to us in the question? Now the body accelerates uniformly from rest. I did not write from rest. Uniformly from rest. Are you following, right? That the body accelerated from rest means that the initial velocity is what? 0. And then we are given the acceleration with which it moved. The acceleration is 2 meters per square second. Now we are asked to calculate what? You are speaking grammar. Magnitude of its velocity. We were asked to calculate what? Mention the quantity, the velocity. Now, which velocity do you think we are looking for here? Final, because the initial is already known automatically to be 0. So we don't know the final velocity. But there is another information they gave to us in the question. Take a look. They stand. Stop reading those grammars. You've read them, you understand it. So hit the particular value given and the quantity it represents, the motion quantity. So what was given here? Distance equal to what? 9 meters. Now let us select our equation. Look at the data we have here. Which equation of motion fits it? Look at the data given to us and we are looking for V. Which equation of motion fits it? Have you checked your equation of motion? Yes, Chijioke, you want to attempt? You know, I've always said, please don't just say anything you just want to say. So when you are asked this question, these things are there in your notes. And I used to take my time sometimes to explain certain things. Why you use a particular question and why you avoid a particular question. Now you said equation 1, Chijioke, you also said equation 1. You did not even check your equations of motion to know what is that equation 1, first equation of motion. What and what did they give to me here? So the first equation of motion, let me ask you now, that's what you mentioned. Do you think it can solve this question? If it can, we would use it. Why do you say it cannot solve it? Time is not in the question here. Are you getting me right? You need time to be able to calculate V using equation 1. Am I communicating? So that one is off. Have you looked through the equation? Do you still want to try? You can still try. He said no. You can still try. At least we're able to find out that equation 1, first equation of motion cannot solve it. All you do is look at the equations of motion. Look at the data given you. You can come up with what can solve it. Please try. I will still force you to try. Equation 3. Put your hands together for my boy. You know, that's correct. Equation 3. So do not underestimate yourself. Don't think that you can't get it. You know, I've always told you your problem is one thing. You're still looking at yourself, smart child, smart child. You are very intelligent. You are super good like all of them are, right? You people are super good. You only need to be confident the more. I think power company has struck. Let's round off quickly, please. Is it correct in saying that third equation of motion will solve it? Yes, that's good. Well done. So we go straight, no time. Square root of V is equal to square root of U and then plus what? 2AS. And we are looking for V. Do you know if I want, I can substitute before simplifying? Is that not so? What if I say I don't want to substitute before simplifying? Now let me make V directly subject of formula. Here, what they ask us to solve, which is V. Is it subject of the formula now? Is V subject of the formula at this point? It's not. Are you getting me? Why do we say it is not? Because of the square. Now, dear friends, I don't want us to substitute directly here before making V subject of formula. I want us to use the knowledge of subject of formula to make V stand alone first. Are you getting me? Before we fix the value. At least I still remember, I've not forgotten. When you were taught subject of formula, we met this guy where we made something subject of the formula there. It's there in your maths notes. All right, let's move on. If we make V to be subject of the formula, what would the equation look like? What would it become? So simply take square root of both. Let's conclude, please. Our V is not equal to, we can now fix the values. What is our U? 0 square. What is that? It's a waste of time. I hope you know that, right? This formula could have just been V squared equal to 2AS, giving you V to be equal to square root of 2AS. So let's move on. And then you come here. This is 2 times. What is our acceleration? 2. What is the distance? 9. So our V is equal to square root of, this is 0, kick it off. This is 36, is that not so?
Yes.
Square root of 36 will give you what? 6.0 meter per second. This is the velocity of the body. Pay attention. I've closed this thing. Let me read out the option again. So you listen, option A, 4.5 meter per second. Option B, 6.0 meter per second. Option C, 18.0 meter per second. Option D, 36.0 meter per second. What's the answer? Option B. Thank you. This is how far we go in our study today at school. Do have a wonderful day ahead. If you get home, rest. Pour water on your body so that you feel cool. Eat and study. And do what? Yes. As a student, what is your occupation? If you are filling a form and they ask occupation, what do you write there? Do you write bank manager, consultant engineer, chief medical doctor, CMD of a Marco hospital? Is that what you feel there? You feel what? Student. And the word student is obtained from, is it Latin or Greek word, which means studios, meaning study. Please, when you get home, rest. Do whatever you want to do that will involve your resting and other stuff. And do what? Study. Look for questions. You have them in past questions. Solve them. Anywhere you are choked, GMAT for the one is just a step away from you. Send a question into our school's group. Are you getting me right? And you will get the help you need. Have a lovely day.